So I want to connect. So the pattern blocks are an example of the area model without a predefined hole, right? Right here, we had to define our hole, and right here, we had to define what 1 is, 7/7 or 3/3. And that's really helpful to do to develop this reasoning and this flexibility. But we can also think about 4/7 plus 2/3 in our fraction circles. And so I'm just going to make this a little bit bigger. We want to see, right? We want to define our whole as sevenths and then thirds. So, right, we want the same exact size whole. So we want both of these. And now we want 4/7. 1, 2, 3, 4. And we can turn on the labels. And then how many thirds? 2/3. So plus 2/3. So just as before, we want to think about adding as putting, right? Just putting these together. And so this is one drawback of the virtual manipulatives. In the physical ones, these can each be separate pieces. So what I'm going to do is I'm going to separate these pieces and have 1/3 and another third. So we can kind of see if we can manipulate them. If we put, right, we can think of adding as just combining, putting together. So if we put these together, we see we almost have a whole. And we see these kind of little slivers here. Maybe I can annotate that to highlight, right? And so we see, what is this little piece? That looks really tiny, but it's the same little piece over here. So it's not just a coincidence or an anomaly. Clear those drawings. And then how much of this guy fits in right here? And if you look, it's almost not quite the same, right? This is now bigger. We see this big chunk here. How much of that? And then this is all overlap. So we need to, so we're clearly going to have one whole, and then this, let me change my colors. This space in red right here, and sorry, again, my circle is pretty awful, is going to be duplicated there. And so we don't know what any of these spaces are when we're here in the fraction circles. And this is maybe could be considered a limitation of this model here, not necessarily the area model in general, but definitely with these fraction tiles or fraction circles, not fraction tiles, is because we don't know what these pieces are, but we can try to find out. Or we can kind of use that same reasoning that we've been using. And this is the importance of thinking about all of the models, the set model and the length model with the area model, not just using one representation. Because look, even putting these together, right, we see this little sliver here, and we don't know how much that is. And we see it here. Sorry, again, my tracing is not very well. Not doing a good job there, but you can see those two are the same exact space. So how much is that? And how would we even be able to find that out? I'm gonna kind of put that on you to try and think about. So we can still use these tools, but they're not as helpful because they're not as flexible. And so that's really an important piece for why we want to define our whole, and then how we know what each of these little pieces are, right? Because we defined our whole, or because really what we started with, right? Because we defined our 1/7 in this way that could be cut into these 3 equal pieces, right? We had this relationship, and right, 3 of the green triangles fit in. So 1/3 of 1/7, or 1/7 divided by 3, gave us this, 1 out of 1/21. And so I know we might have a reluctance to use that, but I want you to see how actually helpful this flexibility is, and the time it took us to define this whole and and then the sevenths and the thirds accordingly helped us then immediately to know that the green triangle was 1/21st, and we didn't really have to think about multiplying 7 times 3 is 21 and find a common denominator first, right? We did that kind of reasoning through when we defined our unit fractions. But here, if we have a third and we have sevenths, it's not necessarily obvious what these little slivers are. Or maybe you can think about it now that I just compared, right? If we see here, this is my seventh. I'm going to outline it. And now I'm going to overlay the third. And so you see this line right here, right? We're going to line that up. And so what's happening to that seventh here? How many, right? If I think about this space, and if I did that kind of same space again, right? Here's my 1/7 now cut into, oh, and I just wrote it, right? My 1/7, right, is now cut into 3 equal parts. I partitioned it. So this little sliver is actually going to be 1/21st. As I'm sure you may have guessed, right? So if we put this as 21 parts, okay. And maybe we'll put those in red. Let's line them up first. We can see that little sliver, right? All of these little slivers that we were originally pointing out are now, right, a 21st. So then we can think about, all right, how much of this 1/3 piece fits in here? 2, and then how much then is left over? And then again, this is part of the limitations of the fraction circles. Is it's kind of hard to deal with fractions when they're greater than 1. It's really easy to see the parts compared to the whole when we're doing with fractions less than 1. But if I filled in these pieces with this guy, maybe I duplicate that and then filled in those pieces, right? So here's my 2 21sts. So I'm going to take these 2 out, right? We're going to use those 2. And I'm going to think about these 1, 2, 3, 4, 5. Oh, and then I'm going to undo these 2 because those 2 are taken care of right there. Well, now we can see we have 1 whole and then the 5 21sts. So when we added the 4 sevenths plus the 2 thirds in this model was really more helpful to figure out that common denominator first so we could fill up the 1 whole and then see how much we had left over.